I'm standing here in the middle of a creek in the Teton Wilderness, and obviously there's no other reason I would be making a video here except to talk about chaos theory. So chaos theory, or theory of perturbations, is something that shows up in functional analysis when you want to ask the question, if I make a small change to the input of a function, how much will that affect the output of that function? I think a good metaphor for this is a creek or a river, like this one. Or not like this one, as the case may be. So if you think about two water molecules that are side by side in a creek, flowing along beside each other, and where they are somewhere down the road when they reach the ocean, how far apart the points where they enter the ocean are, you can say, well, they're gonna be in the same watershed, they're gonna flow down a creek, maybe one gets caught in a eddy for a while, maybe they end up on opposite sides of a lake, and maybe the stream splits at some point and one goes one way and one goes the other, but it inevitably rejoins again somewhere downstream. And eventually they wind up in some big river flowing into the ocean. The mouth of the river is maybe a mile or two wide, so the points where they enter the ocean are within a couple miles of each other. So this would be considered a convergent system. Two molecules that were started close together ended up pretty close together, and it doesn't even necessarily have to be ones that started close together. In the case of a river, you could pick two molecules on far opposite sides of a watershed. Still, they're going to end up in that same river, but generally speaking, it's a stable sort of system where things that start close together end up close together. Because of course, if you pick two water molecules that are far enough apart that they aren't in the same watershed, well, in that case, they're not going to end up close to the same place. But the question that leaves is it possible to have two molecules in the same creek, side by side, that end up in two completely different places? And that's why I'm making this video here at Two Oceans Creek. So right here you can see water is flowing down this way, but if I come around here, I cross here, you can see a tree here. On the other side of this tree, there's water flowing this way. This water, as you can tell by this sign here, it's not going to end up in the same place as the water on the other side. So this is where chaos theory kind of kicks in. The water over here, that's going to flow off to the northeast, join the Yellowstone River, maybe join one of the Plattes, eventually wind up in the Mississippi, flow into the Gulf of Mexico. This water over here, it's taking a southwesterly route down to the Snake, and there it will eventually flow out to the Pacific Ocean. This is an instance where you could take two water molecules that are side by side, and if one goes to one side of this tree and one goes to the other side of this tree, they're going to end up thousands of miles apart when they enter the ocean. So let me make a small perturbation here. If I throw a rock, some of those water molecules that were going to split and go to the Atlantic maybe got splashed and sent over to the side of the creek that's going to split off and go to the Pacific. Just one tiny little change with thousands of miles of difference in the result. That is a divergent system, or in this case, it's a it's a place where two convergent systems split off, so it's a bifurcation, which is something you do often see in functional analysis as well. A function that converges to two different values depending on where you start. And that's what we have here. And this bag of water here, it was originally destined for the Atlantic, but I'm going to filter it and I'm going to drink it, and who knows where I'll be when it comes out of me. It's equally likely to end up in either ocean as long as I'm walking along the divide.